Hi guys. Today we're going to be starting our last section for chapter 7, which is about natural logarithms. We are going to spend today and tomorrow learning about these. We had a little preview of this earlier this week when we were making our secret compartments. So natural logarithms, those are the logs that are an ln log instead of an log log. And we learned that they have a base of the number e. So let's learn about natural logarithms and the number e. We'll start with the number e. So e is an irrational number. An irrational number is a number that cannot be written as a fraction. It's a never-ending, never-repeating decimal. E equals approximately 2.71828. And earlier this week, I showed you that there is a button on your calculator for the letter E, or the number E, since it's a constant. And it's the button right above the ln right here. So we have an log, and right above an log is 10 to a power, which makes sense because log is base 10. And then underneath that, we have an ln button, and above that is an e to the power, which makes sense because ln is log of e. So if you hit second and then ln, it'll type in an e. And since e has to do with logs and logs are the inverse of exponents, we usually do e to a power, which is why it automatically pops up with e to the power of. And if you just type in e to the power of 1, then you'll get what e is equal to. The best way to approach the number e is the same way that you approach the number pi. So pi technically is also a letter. It's a Greek letter, pi, but it's a constant. It's always the same number. So e has the same attributes that pi does. When we want to take a log that's base e, we do not write log base e. You can while you're doing your work, but you should not write it like that in your final answer. And when we give it to you in a question, we are not going to write log base e. We're going to write ln, which means the natural log. It is a lowercase l. I know it looks like an in. It's not an in. It's an ln, log natural. Now, the great thing about this section is that we're actually not going to really learn anything new. We're basically just going to review everything that we've already learned, but instead of using an log log, we're going to use an ln log. An ln log is still a log. So everything that we've learned about logs so far, it works with this. So there's no new information today. It's just working with a new symbol. All right, so let's start by trying to simplify this natural logarithm. So this is the natural log of e to the 6th. Now, anytime you see a natural log, you can put a little base of e underneath it if that helps. And we want to remember that any type of log, natural or log log, is asking the question, what exponent should I put on the base to become this number? Now, since ln has a base of e, this problem in particular is asking, what exponent should I put on e so that it becomes e to the 6th? Well, that's the number 6, right? Like, it's already there. It's e to the 6th. I need to put a 6 on it. So natural log and e, they're kind of like opposites. And so if you're ever taking the natural log of e, you can actually like just cancel them out. You just take your pen and like cross them off. And whatever the exponent was is going to be your final answer. Okay, let's take a look at another example. So this one says 2 times the natural log of e to the 4th. So you've got a couple different ways that you can approach this. You can do what I just taught you, which is cross off the ln and the e. And so this will become just the number 4. And then that's 2 times 4, which is 8. Another way that you can approach this, we learned earlier this week that if there's a number in front of a log, you can take that number and you can make it an exponent. Now there was already an exponent here, so you would just times it with the 4 that was already there. Then this would become e to the 8th. And then again, your final answer would be the number 8. Okay, so again, everything that we learned with log logs also works with ln logs. Let's keep going with this concept of like the expanding and condensing of logs. So this will be our final example for this video. We will have a second video where I talk about completely different problems. So in this final example, I've given you logs. Again, even though it doesn't say log, it is still considered a log. And I want you to take it from its expanded form, and I want you to condense it into a single log. So again, everything we learned earlier this week still applies. So any number that's right in front of a log is going to become an exponent. So the first step I'm going to do is I'm going to take the 2 and I'm going to make it an exponent on the 5. And 5 squared is 25. I should probably actually figure that out. And then earlier this week, we learned that if you have 2 logs that are being added together, you can squish them into one log using multiplication. So I'm going to write ln just once, and then I'm going to multiply 7 times 25, which is 175. All right, so the final answer to this problem would be the natural log of 175. Since the directions said to write it as a single log, I would stop here. I would not type this in my calculator. It does want the word log in your answer, and ln is a type of log. It's important on these problems that you stay consistent. So if you started with an ln log, you do want to finish with an ln log as well. You don't want to accidentally change it to an log log halfway through the problem. This concludes our first video for today.